All right, I'm going to jump all over the place here. As you guys can probably see, this is round 9, not round 1. This was supposed to be trivia for today, so I'll have to make it up to you somehow next week. If you're looking at this, you're probably going to recognize these questions. They came from the study guide handout that I gave you yesterday in class that was like a practice test. Um, it says, what's the name of the least reactive group of nonmetals and why are they not reactive? The least reactive group is your noble gases. And why is it that they are not very reactive? Well, what does every single atom out there want to have? They have a full outer outside shell, which we're going to also call valence. Okay, so remember that your valence shell is your outside shell, and for those guys, for all of the noble gases, which that's everybody over here, for all of those, they're completely full and they're very happy. This one says predict the formula of the ionic compound that's formed with the following reaction. Well, for this one, it's not asking you to balance, okay? It is not asking you to balance. No, that's not our goal. So where we're normally writing them out and we're saying, okay, over here on this side we have K and O and Mg. We're not doing that. What we're looking for is what are we missing over here and how do you balance them? It's going to be ionic. So remember, for ionic, we use the crisscross method. Okay, so we have Mg, we have O, so that means that we're going to need to put potassium, which is K, and we're going to need to put nitrogen, which is N. Okay, so now I'm going to go over to my physical science reference sheet. I'm going to find potassium. What group is potassium in? What is its oxidation number? Remember, it is a +1. Okay, then let's go over here. These guys are a 0. This group is a -1. This group is a -2. Nitrogen's group is a -3. Okay, so that means potassium is right here. That's a +1. Nitrogen is a -3. So I would write that over here, that potassium is a +1 and nitrogen is a -3. Now remember, we're going to drop our charges and we're going to crisscross them. So I'm going to take the 1 over here and the 3 over here without their charges. And so it's going to be K3N. Do I need to put the 1 right here? No, don't put the 1. It's just like math. It's understood that it's there. For these problems right here, there's a separate video here in YouTube and in my YouTube that talks about how to balance equations. So I would rather you just watch that one than having to do this. At the bottom, it says name the following compounds. Identify if they are ionic or covalent. Don't forget ionic, and there's another video on that, is a metal, which is going to be your donor, and a non-metal. Okay, covalent, meaning to share. Covalent is non-metal and non-metal, Nm and Nm. Okay, potassium and chlorine. Is potassium a metal or a non-metal? Well, look back at your periodic table. Remember, your stair step here is your metalloids. So pretty much everybody that's kind of touching that stair step in general right there is a metalloid. Almost everybody over here is a metal. The only exception is hydrogen. Hydrogen's a non-metal. It's over here because it has 1 valence electron. Otherwise, it wouldn't have fit. Remember, you can predict the characteristics of an element when it is underneath the other elements. So these guys are the most reactive group on the periodic table because they all have 1 valence electron. So that's the reason that this chart looks as funky as it does. Over here, these are your 17 nonmetals. Okay, so to the right is your non, to the left is everybody else, and they're metals. There are good conductors, conduct electricity, conduct thermal energy. They're usually solids, they're usually brittle. Sometimes they're shiny, those kind of things. In this case, potassium is in group 1, so this is going to be a metal and a non-metal, so that tells us that this is ionic. Carbon and chlorine are 2 nonmetals, so this is covalent. Iron and oxygen. Iron is a metal, and so that's going to make this ionic. Aluminum and oxygen. Aluminum is a metal, and so that's going to be an ionic bond. Okay. I'm going backwards now to round 5. This is round 5. It says it at the top, so everybody should have these available to them. If not, these videos are on YouTube, so you guys, I know you just want to sit at home and watch these videos all day long. It says an atom contains 9 protons, 10 neutrons, and 10 electrons. Is this an ion or an isotope? And I'm pretty sure that Nick asked me this exact question the other day. Can you be an ion and an isotope at the same time? And the answer is yes, you can be anything you want to be. So in this case, we have, I know right off the top of my head that this is going to be an ion because it has 9 protons and 10 electrons. Normally, if you have 9 pluses, you have 9 minuses. But in this case, we have an extra minus. So that means it's got a -1 charge. If you have a negative charge, what are you? You're an ion. I have no idea if this is an isotope yet because I haven't looked at the periodic table. It says, what would it be called? So let's look over here on the periodic table and find number 9, which is this guy right here. It's fluorine. So I'm going to write, fluorine is spelled Fluorine. Fluoride is what they put in your toothpaste. Fluorine has 9 protons, as it tells us up here. It has 10 neutrons, and it has 10 electrons in this case. So I'm going to look at the periodic table, and I'm going to see what does that tell me about its mass. And down here, it tells me that fluorine has an atomic mass of 19. So let's see. 19 minus 9, that's how we solve for our neutrons, equals 10. So is that the normal number right there, 10? Yes, it is. So is this an ion or an isotope? It's only an ion. And we would just write this as fluorine. If you want to write it out, you can write fluorine. Or if you need to put it into ionic notation, then you're going to say fluorine. And we have one extra negative up here. So we're going to write fluorine minus 1. It goes at the top. It doesn't go at the bottom. I'm not telling you that I have 1 fluorine. I'm telling you that every fluorine I do have has a -1 charge. So that means that it has bonded up with someone else somewhere. What's the atomic number, atomic mass, and number of protons, neutrons, and electrons for potassium and for aluminum? Potassium is K, aluminum is Al, and you just need to locate those on the periodic table. I'm not going to go through that on the video. How many neutrons does the most common form of fluorine have in its nucleus? Well, we just answered that question up there. Fluorine, I'm going to go over this one more time though, because everybody seems to forget how to figure out the number of neutrons. The most common number of neutrons that it's going to have is going to be what's on this periodic table. The periodic table is the normal things, it's the most common things. So in this case, we have an atomic mass of 19 minus 9 protons equals 10. So the most common form of fluorine has 10 neutrons. This says an atom contains 11 protons, 12 neutrons, and 10 electrons. Is this an ion or an isotope? And what would it be called?